All right, for this review problem, we're going to prove that if n is an integer, then n is even if and only if n plus 2 is even. So this is an if and only if proof, so there are going to be two directions. So first off, let n be even. And the goal is to show that n plus 2 is even. So by definition, there is an integer k, so that n is equal to 2 times k. Okay, that's all well and good, but what I really care about is n plus 2. So n plus 2 is equal to 2k plus 2, and I can factor the 2 out. So n plus 2 is equal to 2 times something, and by the axioms of arithmetic, that something is an integer. K plus 1 is an integer. Because k is an integer, 1 is an integer, add two integers, we get an integer. Therefore, n plus 2 is even by definition. And so that's one direction. The other direction. So for this direction, we'll assume that n plus 2 is even and end up that n is even. So let n plus 2 be an even integer. So this is going to go very much like the first part by definition. There is an integer. Now I'm going to choose a different letter, J. I used k before. If I wanted to use k here, that's all right, because I'm starting a brand new proof. Just simply a matter of preference. So that n plus 2 is equal to 2 times j. Well, that's well and good, but what I care about is n itself. So subtracting, n is equal to 2 times j minus 2, or n is equal to 2 times j minus 1. And let me mark parenthetically. On the top one, I deliberately spaced out the equations where I have the equal signs lined up. For this one, I wrote it out in sentence form. Both are perfectly all right. I just wanted to give two different ways of writing it so that you can see both techniques. Okay, by the axioms of arithmetic, j minus 1 is an integer. J is an integer, 1's an integer, subtract them, you get an integer. Therefore, n is even by definition. And so that is the end of the proof. And so we use some kind of end of proof symbol to denote that that's the end.